Hey guys, so this is our first lesson. It's on rational numbers. Okay, so to start up, we're just going to go ahead and we're going to get the definition of rational numbers, which is right here. All right, so I would go ahead and put this definition into your notes. So a rational number is a number that can be written as a comparison of two integers and expressed as a fraction. Okay, so what that means basically is, if you don't remember, an integer is going to be basically a whole number, whether it be negative, 0, or positive. So any of those are going to be integers. Okay, so then a rational number is a number that can be written as a fraction that uses two integers, right? So the numerator, or the top number, is going to be an integer, and the denominator, or the bottom number, is also going to be an integer. All right, and then we'll talk a little bit more about that as we go on with the lesson. Okay, so next we have here just examples of how rational numbers can be written. So just to give an example, a percent is going to be like 2%. A fraction would be something like 1/5. A decimal would be something like 5/10. And a mixed number would be something like 5 1/2. Okay, so there's just some examples of those. All right, moving on. The root of the word rational is ratio. Describe the relationship between rational numbers and ratios. Okay, so this is something I just want you to take a second to think about. And then when we join back up as a class, we'll talk about it together. All right, so if you want to go ahead and think about that, feel free to do that. The next thing we're going to do is we've got this real world link. If you like sports, this one's for you, especially if you're a baseball fan. So during a recent regular season, a Texas Ranger baseball player had 126 hits and was at bat 399 times. Write a fraction in simplest form to represent the ratio of the number of hits to the number of at-bats. So we have 126 is going to be our numerator, and 399 is going to be our denominator. All right, so pretty simple there. That's an example of a ratio, also a fraction. Moving on again, I think this chart right here is very good. It shows you just how rational numbers work, where they fit in, where each, sorry, there's a piece of dust on my screen I was wiping off. Anyway, so it tells you about rational numbers, about different types of rational numbers as well. So that inner circle, the green circle, is natural numbers, and I'll go ahead and write this for you. This would be good stuff to put in your notes, including this chart. Okay, so a natural number is going to be your counting numbers. All right, so that means you start at 1. So 1 is the first natural number. So 1, 2, 3, 4, 5, etc. Okay, 0 is not a natural number because you don't start counting at 0. All right, whole numbers. These are going to be counting numbers or natural numbers, but also with 0. So plus 0. Okay, sorry if my handwriting is bad there. I'm getting used to writing with the Surface pen. So that's your whole numbers in that yellow circle. Next you have integers. Okay, so integers are just like whole numbers. The difference is they are both positive and negative whole numbers. All right, so that's all an integer is. You can have positive and negatives. Natural numbers and whole numbers do not include negatives. All right, so that's integers. The last one would be your rational numbers, which is what we're talking about together, or all together today. And rational numbers are numbers that they include all three: natural numbers, whole numbers, and integers. But rational numbers are also numbers that can be expressed as a fraction of integers. Okay, so one example they give you right here is 1/2. Okay, that one is a rational number again, just because it has an integer on top, 1, and an integer on the bottom, 2. Okay, so this is just an example here of a rational number. All right, moving on, we have a couple more vocabulary terms. So the decimal form of a rational number is called a repeating decimal. Okay. And then if the repeating digit is 0, then the decimal is a terminating decimal. Okay, so examples of these. A terminating decimal is going to be, oh, and guys, I would go ahead and write this stuff down as well. So a terminating decimal is going to be a decimal, let's say, if we have the fraction 1/4. Okay, so 1/4, if you were to type in 1 divided by 4 into your calculator, you would get the decimal 0.25. Okay, this is an example of a terminating decimal because the repeating digit is 0. So if you were to write in zeros here, nothing changes, right? Those are the same thing, 0.25 and 0.25, 0, 0, 0, 0, etc.
Hey, let's go to my room and I found these posters. Do you want them?
So there's your example. Sorry, a little interruption, but that's your example of a terminating decimal. Okay, so 0.25 or 25 hundredths is going to be a terminating decimal. One repeating decimal that is not terminating would be something like 1/3. Okay, and you'll notice if you type that into your calculator, you'll have 0.3333, and it'll just go on as many digits as your calculator will allow. Okay, so this one is not a terminating decimal because the repeating digit is 3, so obviously the repeating digit isn't 0. Okay, so another way of writing this is going to be 0.3, and then you just put the line over the top of it. All right, that's an example of a repeating decimal that is not terminating. Okay. So moving on, we'll go ahead and do example 1 here. So write each fraction or mixed number as a decimal. So the first one is 5/8. Remember, whenever you have a fraction, that just means division. Okay, so fraction equals division. All right. So if you were to go ahead and type in 5 divided by 8 in your calculator, basically it's the same as what they're doing right here. It's just division. This is just their long division. You would get 0.625 or 625 thousandths. Okay, so that's all that one is. We won't worry about example 2. If you feel like you need extra practice though, feel free to take a look at that. That's fine with me. All right, next we have these problems here. I would like you to go ahead and pause the video for just a second and go ahead and work these out the same way we just did example 1. So for 3/4, you'll type in 3 divided by 4, and so on with that. Okay. And we will talk about those when we come back together as a class. All right. So next up we have example 3, it's another baseball one. In a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits in 530 at-bats. To the nearest thousandth, find his batting average. Okay, so to find this, you can basically just follow the steps that they have put here for you. So you divide the number of hits, 175, by the number of at-bats, 530. Hit enter. It's going to give you this long decimal in your calculator, or depending on your calculator, it might not be quite as many digits, but you'll get something similar to that. The instructions tell you to round to the thousandths place. So this is kind of where you just need to reach into your memory and remember where the thousandths place is. So that's going to be that 0. Okay, so right here, that's the 0, that's your thousandths place. Okay, so you're rounding to that digit, which means you need to look at the digit behind it, the 1, and that'll tell you if you round up or down. Of course, with 1, you're going to round down, so your batting average is going to be right here, 330 thousandths. Okay. Now at this point, I want you to go ahead and stop, and I want you to try this problem, problem E. It's a NASCAR problem. So if you're a NASCAR fan, lucky you. Go ahead and try that and get that answer for E, and we'll talk about that when we come together as a class again. Okay, so the next one, example 4, we have write 0.45 as a fraction. Okay, the proper way of saying 0.45 is 45 hundredths. Okay, and that is really important to know because then it's very easy to write. Right, so if you think of 0.45 as 45 hundredths, this says 45 hundredths right there. Okay, so then once you get that 45 hundredths, you can simplify that. The easiest way to do that is to know, So the easiest way to do that is to divide by 1, okay? And any number 1 is going to be n over n, where n is just any integer, okay? So then we would have, for this scenario, we know that 45 and 100 are both divisible by 5, so I'm going to do 5 over 5, which is the same as 1, and I'm going to divide both the numerator and the denominator. So 45 divided by 5, I'll tell you, is 9. 100 divided by 5 is 20. So our simplified version would be 9 over 20, or 9/20, and that's the answer that they give you right there. All right. Okay, so our last example together in this video, write each decimal as a fraction or mixed number in simplest form. All right, so negative 0.14, which would also be negative 14 hundredths. Obviously, that's the easy way to say it, is 14 hundredths. So you have 14 hundredths, so that 100 makes it really simple for you. And then don't forget your negative. Okay, so you have negative 14 over 100, and that's going to be what you would write here in F. So negative 14 hundredths. All right, and that'll be the end of the video. Everything else will go together, go through together as a class. So yeah, see you there.